Good afternoon, folks. Thanks for coming in. So how's the WSO2 gone so far? Good? Great. So as Ishara said, I don't have any slides, so I thought like slides are a bit boring, so I'll work on sort of demos and show how things work. So let's see how it goes. So this session is about microservices security. How many of you have microservices deployment in production? Okay, great. Yeah, so in this demos, I'll be using WSO2 Identity Server with Ballerina. How many of you heard of Ballerina? Okay, so Ballerina is a compiled, type-safe, concurrent programming language, and if you come to our Ballerina day on this Thursday, you will learn more about it. Okay, so when it comes to microservices security, we talk about 4 main areas. Right? The first area is edge security. It defines how you authenticate the end user to a microservice. Right? When it comes to microservices, this end user is mostly a system. Right? It can be a system accessing a microservice just by being itself, or it can be a system which is accessing a microservice on behalf of an end user or a human user, right? Everything I do now, you should be able to reproduce it, or everything is in my Git repo. I'm not doing anything extra. Everything is here. And if you look at this diagram, so it explains how the edge security works, right? So most of the time, you have your microservices deployment, and you don't expose all these microservices to the outsiders. So outsiders in the sense for other systems or client applications. Whenever you want to expose a set of microservices to the outside world, then you use an API gateway, right? So you will have an API which will front and redirect the traffic to the microservices that you want to expose to the outsiders. And these APIs will be consumed by other systems, right? So as you can see in this image, it can be a web application or a mobile application. So let me quickly walk you through this flow. So you have the end user. End user needs to log into this particular web application. So this is a scenario where a system accessing a microservice on behalf of an end user, right? So end user first logs into the service provider using some kind of a federation protocol. It can be SAML, OpenID Connect, Tabless Federation, or any kind of a federation protocol. Let's say it's OpenID Connect, which is based on OAuth2. So once you logged into the web application, now web application, which is actually a system, it needs to invoke a microservice via an API. Right? Most of the time, for edge security, we use OAuth2. Anyone not familiar with OAuth2? Everyone, I guess, heard of OAuth2, right? At least the Facebook, the data breach recently, right? So it's an exploit of their OAuth2 implementation. So OAuth2 is very popular, and it has become the de facto standard for securing APIs. So now you have an access token here, right? So you get the access token from this IDP. Now the service provider has its access token, and you access an API and will pass that access token along that request that will come to the gateway. Now in gateway, so this particular access token, if you are familiar with OAuth, access token is an arbitrary string, right? So this arbitrary string, so there are 2 types of access tokens. So if it's just an arbitrary string, we call it a reference token, right? That means it's just a token. Nobody can say anything just by looking at the token. If you want to validate the token, you have to go to the token issuer, right? The other token type is called self-contained access tokens. Self-contained access token is a JWT, right? So once you get a self-contained access token, to validate the access token, you don't need to go to the issuer. If you trust the issuer, if you know the public key of the issuer, you can simply validate the signature of the JWT and accept it as a trusted one. So here in this case, we assume this particular access token is a JWT. So you pass the original JWT here and get a new JWT, right? So this is the security token service in your deployment, right? None of these microservices in your deployment, they even don't need to worry about the IDP. They will only trust their own security token service. And there will be a trust relationship between this STS and this IDP, right? So you get a JWT from this IDP, pass it to the STS. STS will create its own JWT, right? So what's the difference between these two JWTs? New JWT is signed by this STS, right? And there's another key difference. That's the audience value. Whenever we issue a JWT from a token issuer, we issue it for a particular audience. Okay? This is a JWT, this is the access token for this particular audience. And whenever you receive an JWT, while you are validating it, you must first check whether it's a JWT issued to you. That is done by validating the audience value. Right? So the JWT issued from this IDP will carry an audience value pointing to the API or the API gateway. And this JWT issued by the STS will carry an audience value pointing to the microservices deployment or the order processing service. Right? So edge security terminates here, and this new JWT will carry the user context. Right? So authentication part is done, but still, from the API layer to the microservice layer, we need to pass a user context. Why? That is for authorization, right? We need to know what this particular user can do in individual microservice. So you need to pass the user context. Now we have the JWT here. So that's the edge security part. So the next important aspect in microservices security is service-to-service communication. How you secure the communication between two microservices, and that's the most challenging part. If you take a monolithic application, in most of the time, you will only find 1 or 2 entry points. It will be like 443 or port 80, right? But in a microservices deployment, you will find hundreds of entry points. All these entry points may not be exposed to the outsiders, but still, in your internal deployment, each microservice is an entry point. When you have multiple entry points, we have a broader attack surface to secure. So that's the most challenging part. So we need to worry about securing the communication between these microservices. When securing microservices between services, we need to worry about 2 things. We need to see how we are going to pass the end user context from one microservice to another microservice. For example, if order processing microservice talks to inventory microservice, we need to know how we are going to pass this user context from here to here. How to pass the end user context. Then the other aspect we need to worry about is how to pass the service context, right? Service context order processing service. So that is done by using different service-to-service security communication patterns, right? The first pattern I'm going to show you is this one, service-to-service authentication with JWT, right? So here, so number 1, number 2, number 3 are just like to spin up these servers. After that, you get a JWT, and you pass that JWT to this order processing service. So think about number 5 here is a call initiated from the API gateway in the previous diagram, right? So it comes here, then in this pattern, you will just pass the same JWT you got from the gateway across all the microservices, right? You can pick the pattern you want based on the level of security you want, right? So this has some disadvantages too, right? But this is easy to implement, but this has some disadvantages too. The reason is, when you pass the same JWT from here to here, both the microservices should worry about the same audience value, right? Then also, if there are some scopes attached, they will carry the same scopes. Okay? So let's try to see how to get this pattern implemented. Okay? The first thing here is I need to spin up the STS, the WSO2 identity server. Right? So if you go through these steps, all are documented here. So I have identity server instance. It's available in Docker Hub as an image. So if you run this run STS command, it will just pull the image from the Docker Hub. Right? So this will spin up the identity server. It will take about like 30 to 40 seconds. And till that gets started, the second step is we need to spin up this order processing microservice and the inventory microservices too. Right? So both the microservices are written in Ballerina. I'll go to the code later. I'll try to spin up the order processing microservice. Just run this script. It will spin up the order processing microservice running on HTTPS 9008. In the same way, spin up the inventory microservice. So our deployment is now up and running. So I have my STS, I have my order processing microservice, and the inventory microservice. Okay, so this is up and running now, STS. Now, step 4, right? So I need to invoke the order processing microservice. To invoke the access the order processing microservice, I need to have a JWT, right? So I am using an OAuth grant type, and I need to get an access token from the STS, right? To do that, I use this command here, this shell script. Right. Okay, so this will talk to the STS, and it will generate or get an access token, which is a JWT itself, right? So this is a JWT. So this is base 64 URL encoded JWT or a compact serialized JWS. Now, if you want to see what is in it, right, there's a nice plugin here. Okay, if it is not working, go to jwt.io and paste it here. It will show you what is in it, right? So this JWT has this particular audience value, right? That means this JWT is good enough to a microservice which accepts tokens under this audience value, right? And this has a token issuer, right? So when I secure microservice, I will only accept tokens from a given issuer. And also this carries a scope which says place order, right? Now let's have a look at our microservice. So if you look at this one, okay, so this is service order processing, right? So this is the auth provider which enforces JWT-based authentication for this particular Ballerina service. Here you can see I'm using JWT, and issuer is WSO2IS, and this will only accept a JWT with this particular audience value. Right? And also, to validate the signature of the JWT, it looks for a key in this particular key store with the certificate alias WSO2 Carbon. Right? I'll go to the rest later. Let me try to invoke this service. Okay. So I have this access token, and I need to export this to export token. Okay. Now invoke this. So this will take the value of the token from the shell environment and invoke the order processing microservice. Okay. So order created successfully. If you look at this one, here you can see it got a response from the inventory microservice, right? So this is not just about authentication, this also does authorization, right? So if you go back to the code here, this is the order processing microservice. If you look at the service config, for this order processing microservice, we have enabled authentication. And also, under the resource config of this place order method, we say you need to get a token with the place order scope. If you bring a token with a different scope, you will not allow to access this microservice, right? And then again, when this microservice invokes the inventory microservice, it has to pass the same JWT. So that's the pattern that I'm demonstrating now. To do that, I get the JWT from the runtime context, runtime invocation context, and I set it as a JWT to the outbound flow, right? So here you can see inventory endpoint is defined here, right? This is a client endpoint pointing to the inventory microservice, which is running on port 9009, right? Any questions up to now? Okay. All good, or you didn't? Is that good, or you got something? Or? Yes. So when you don't ask questions, there are two assumptions I make: either I didn't do a good job, or else you understood everything. Right? Okay. Then the second pattern, right? In the second pattern, I'm going to do a token exchange, right? Rather than passing the same JWT that you got to order processing microservice to the inventory microservice, now the order processing microservice will talk to the STS, pass your current JWT, and get a new JWT with a new scope and with a new audience, right? So this is much secure pattern, right? So let's see how to do that. So I'm using the same STS, right? Okay, with token exchange, and I'll start the order processing microservice. Same for inventory. Okay. Okay, and now same for client. Okay, so now let's once again get a JWT. Okay. Now let's do the same thing. Export this to the token environment variable. Now invoke the microservice. Right? So you get the response. If you go to order microservice, you can see the response comes from inventory microservice. But if you want to see the exchange microservice, let's do something here. Let's add a log. This is the one, order processing. Just uncomment this one. So here you can see you get the access JWT from the inbound request, and you exchange it token to the token endpoint of the identity server using the JWT grant type. And you get a new JWT which has a different audience value and a different scope. So here you can see I am passing update items as a scope for the token I want to get to access the inventory microservice. Right. So let me save this one and start it again. Now it should print the JWT. Okay. So this is a new JWT. And if you go here again, here you can see you have the new scope and also new audience value, right? And if you look at the inventory microservice, this should have this particular scope. This is a scope that we got the token for, right? Any questions? Yeah. Do you have a mic? Okay, maybe after this one. Yeah, sure. Okay, so next demo, I'll show you how to do authorization, right? So there are two samples I have for authorization, right? So one is using OPA. OPA is for Open Policy Agent. How many have heard of OPA? Oh, great. So OPA is becoming popular, mostly in the microservices domain for access control. And it's not just for microservices, but it can be used for anything. It has its own programming language to write policies called Rego. And it has defined its own request response formats, right? So I'll show you how to do that. So this is the setup. It's the same thing that you saw before. You have the order processing microservice. You get the JWT, right? And now, before deliver, I have one microservice now, right? Earlier, we did authorization with scopes, right? So now we don't worry about scopes. We do authorization based on access control policies defining OPA, right? Now, once you get the request, the order processing microservice will build an OPA request and send it to OPA server, get the response back, and if it is permitted, it will let the user access a resource, right? Now, I need to go to the fine grain OPA. Okay, start the order processing microservice. So everything is like container-based other than these ballerina services. So you don't need to worry about setting up anything, IAS, OPA, anything. You can just go to this Git repo and run the commands. They should work as it is. It works for me. Now go to OPA, and you can spin up an OPA server. Right. So it is once again a container-based one. Right. Now it's started. So order processing microservice is running, OPA server is running. Now, same way, our STS is also running. Now I need to get a token again. Okay, I got a JWT, and if you look at this JWT, I think it doesn't have any scopes because we don't worry about scopes now. There are no scopes here, right? Now I need to export this to token. Okay, now let's invoke the service. Right. Okay, order created successfully. And if you look at the order, this is the request. This is the authorization request created by the order processing microservice and sent to the OPA server. It's a JSON message, right? And this is how the OPA policy looks like. So, OPA, right? So Rego is the language. So this says you are allowed if your username is admin@carbon.super, and if you are doing a post to orders, you are allowed, right? So let's change this. Let's say admin2. Right, so my Docker container is mounted to a local location to pick this policy. So if I restart my OPA server, it will load the policy. Okay, so now if I invoke it, it should fail because my username is admin@carbon.super, but the policy is expecting admin2. Right, user not authorized. Right. Okay, so that's a very simple example. So OPA language, if you look at it, it's very simple when you compare it with SACMA. Right. So this is a very simple language, but you can use its own expressions, those stuff, right? Any questions? Did you get the mic? Or? Yeah.
You just answered my question.
Oh, great.
hate mics. No, that was really interesting and a really useful demo. I'm just interested, as somebody, a lot of us aren't yet users of Ballerina, and I know it's an emerging technology. Can you give us an indication of how existing frameworks could fit into this? I presume like Spring Boot or .NET, do they support all this natively? I just wonder, what extra efforts, I'd love to go look at your code and have a look. I'd love to know, if I can implement it with my existing frameworks.
Yeah, so the communication between the Ballerina microservice and the identity server all through REST endpoints, right? They are all standard REST endpoints. So if you use any programming language, you can use that. So if you use Spring Boot, it has its own connectors too. Like you can just enable OAuth and put a JWT endpoint. You can use that with identity server. And all REST endpoints. Sorry? Yeah, yes. Audience validation, those stuff can be done at the programming language, yeah. So language should support that. Yeah. Okay. So last demo. So anyone who loves SACML here? Heard of SACML? Okay. Okay, great. So SACML is good, like it's very powerful language, but it's a little bulky. Like you can see why it's bulky. So this is a demo implementation I did this morning. So let me quickly show you that too. Right. So I need to go to Finebrain with SACML and spin up the order processing microservice here. And I have another identity server instance and another Docker image, which will just run as a SACML engine with all the policies built in. Right? You don't need to do anything. This should work straightforward. Okay, so I'm spinning up my SACML PDP. So this may take some time. So till that gets started, any questions? Any other questions? Okay. So those who have production deployments of microservices, like how do you authenticate the communication between services? Any comments? Because what I have seen is many people, so we've been talking about microservices for a long time, like 4 or 5 years, but now only we see people starting to deploy microservices production setups. And most of the time, they don't worry about service security. They simply trust the network. So once you do the edge security stuff at the gateway, rest you don't worry. But once again, we now pushing towards or moving towards to a zero trust network. So you don't trust the network, so every connection has to be authenticated. Right? So one reason I guess most people don't do this stuff is the complexity in doing that, implementation stuff. So we at WSO2, we are working on a project to make everything simple, and through one configuration file, we'll be able to deploy everything and configure security. That's something we are working on too. Yeah, I think this got started. And once this got started, actually, you can log into the identity server. This is running on 9445. I'll show the SACML policy. Policy view. Okay, this is a SACML policy. This says administrator, right? No, the user can do a post to the orders resource, right? If the administrator, if the user is in the admin role, right? So user can be anyone, but if the user is in the admin role only, he can do a post to the orders, right? So this is a policy pre-built, deployed in the identity server Docker image. Now let's run it again. Right, I need to get a token again from the STS. Okay, now if I invoke the service, it should do access control with SACML engine. So you can see this request, right? And you got a response, which is permit. That's why you can access it. Now, if I change it, to change this, you need to go to policy administration, the processing, let's change this admin 2. Right? And the identity service is connected to an LDAP. And And in the authorization request, we get the username, and based on the username, we go to the LDAP and find the roles corresponding to that particular user. Okay, save policy, and I need to dispatch this to the PDP. Okay, so let's validate this one. Admin 2. So this means if we have done this properly, it should fail this time, right? Because admin doesn't have the admin role 2. This is the admin user. If you look at roles, he only has admin role, not admin 2. Now, if I just run the client again, it should fail. It fails, right? Okay, so so everything I did, so it's available here. So please go to this link, and I have tweeted this link. So my Twitter account is Prabhat. You can find this link and try out these examples. It should work straightforward. Any questions? Okay then, thank you very much. Okay.